In this video, we are going to practice identifying transformations when we are given an equation in vertex form. And in this case, we are going to practice identifying all of our transformations together. In the previous videos, you have only done stretches or compressions, or vertical and horizontal shifts. So I want to have an example where we look at every piece together. So to start off with, I show you our equation in standard form. So there might be a positive a or a negative a, and then x minus h squared plus k. And when we look at an equation, we are going to look for four different things. We're going to look first at the sign in the front, and that's going to tell us is there a reflection. Then we are going to look at a and ask, is there a vertical stretch or compression? Then we are going to look at h to figure out if there is a horizontal shift. And then we are going to look at k to see if there is a vertical shift. Some equations will have all four, some might only have a couple, but by looking for each portion will help us figure out will help us keep track of what we're doing. And then once we know our transformations, we can write our axis of symmetry as always x equals h, and then our vertex is h comma k. So let's look at what this looks like in an example. So first, we have the equation y equals negative x minus 2 squared. So we are going to first identify a, h, and k. In this case, the a is negative 1. And I know it's negative 1 because there's no coefficient written there, so I'm going to input a 1. So a is negative 1. H is positive 2. Remember, h follows the opposite sign. And then because there is nothing written here, k is 0. So now that we know our values for a, h, and k, we can list our transformations. So first I look for a reflection. Because this sign is negative, there is a reflection. So I can write that we have a reflection over the x-axis. And that is because a is negative. Next, I look for the value of a to see if there's going to be a stretch or a compression. Because the magnitude of a is only 1, 1 does not stretch or compress our graph. So there is no stretch or compression. So now we move on to step 3 and look for the horizontal shift. In this case, there is a horizontal shift because h is 2. And remember, we're looking for the value of h. Since h is a positive 2, we are going to go to the right 2 units. That is a horizontal shift. And then I look for my vertical shift, which is going to be at the end. Because there is no number k, there is no value for k, we do not have a vertical shift. So now we can write our axis of symmetry. Our axis of symmetry is x equals h. Since h is 2, our axis of symmetry is x equals 2. And lastly, our vertex is the point h comma k. So I'm going to take h and k that I identified, and our vertex is 2, 0. And now we have identified the 3 critical things you need to get from vertex form. You need the transformations, you can get the axis of symmetry, and you can get the vertex. Now we have another example. In this case, they give me y equals x plus 3 squared minus 1. And I'm going to first identify a, h, and k. Now a would normally be right here. So we have a, h, and k. A would be our coefficient in front of the x squared. Because the coefficient is not visible, we know that there is an invisible 1 right there, so a is 1. H is going to follow the opposite sign of what we see in our equation. So h in this case is -3. And then k follows the same sign. So since k is -1 here, we are going to take -1 for k. Now that we have listed a, h, and k, we can identify our transformations. In this case, we first look for a reflection. Is there that leading negative out here? Because there is no leading negative, there are no reflections. Then we look for the value of a. A is 1, and when we multiply something by 1, we are not changing how it looks, so we are not going to have any stretches or compressions. So we can move on to h and k. H is my horizontal shift, and because h is -3, I know I have a horizontal shift left 3 units. I have gone left 3 units because this is a -3. K is -1, so that is my vertical shift. So I have a vertical shift, and that negative tells me I am going down 1 unit. We recall that our axis of symmetry is x equals h. So in this case, x equals -3. And then our vertex is the point h, k. I know h is -3 and k is -1. So my vertex is -3, -1. So if you can first identify a, h, and k correctly, you can then write all of the transformations, the axis of symmetry, and the vertex with a lot more ease. We will do one more example where we are given the equation and going to list the transformations. In this case, I have y equals 1/3 x squared plus 1. That 1/3 is going to be my a. Now there are no parentheses here. There's nothing with the x being squared, so h is 0 because h is not present in our equation. And then k will be +1. Now that we know our a, h, and k values, we can identify our transformations. Do you think that there's going to be a reflection in this? There is no reflection because a is positive. Will there be a vertical stretch or compression? There will be a vertical compression because a is a fraction, and we would say that it is a vertical compression by a factor of 1/3. H is 0, therefore there is no horizontal transformation. K is 1, so there is a vertical shift up 1 unit. So remember, our axis of symmetry is x equals h, so in this case it is the line x equals 0, and our vertex is the point h, k, so our vertex is 0, 1. In the last part of this video lesson, we will talk about how we can write an equation in vertex form when we know some of the transformations. So I want to remind you, our equation in vertex form is y equals a times x minus h squared plus k. So now that we know what our equation is, we're going to look at what we start with as our values for a, h, and k. When there are no transformations in a quadratic, a is 1, h is 0, and k is 0. Then we can look at our transformations and figure out how that's going to change these numbers. So in this example, I know that I am reflecting across the x-axis. Well, that means that A is negative. So if A is negative, then I can change this 1 to become negative 1. Then I know that I am shifting down 1 unit. That means that K must be negative 1, because that's how we move down 1 unit. So this K is 0 is going to go K is negative 1. Now H has not changed. There are no more transformations to deal with, so H is still going to be 0. So now we can rewrite our equation with the values that we have. So we have y equals negative 1 x minus 0 squared minus 1. Now, last step as a mathematician is to know that we will not leave things like minus 0 there. So I'm going to change that coefficient. I'm just going to write the negative. So we're going to rewrite that as y equals negative x squared, because x minus 0 is just x, minus 1. And we have now written an equation in Vertex form using the transformations. We can try one more example. So we have a vertical stretch by a factor of 3. So that means that A must be 3. So I'm going to change A is 1 to become A is 3. Now I'm going to shift right 5 units. So that means that H will increase by 5. So 0 plus 5 gives me 5. Then I am going to shift up 1 unit, so K will increase by 1. So now we have K equals 1. So we can substitute these directly into our formula. I'll remind us our formula is A x minus h squared plus K. So I can substitute in A is 3, so y equals 3 parentheses x minus 5, because h is 5, squared plus 1. And that is how you write an equation in Vertex form when you are given the transformations. Have a great day.